Now that you've mastered graphing equations, we're going to step it up a notch and graph linear inequalities. So before, when we graphed inequalities, we had just something like x is greater than 3. And you would make a number line, right? And it's not or equal to, right? So it's an open circle, and it's all those values greater than 3. And this is good because we just have one variable, which means we have one line. But what do you do if you have an equation that's y plus x is greater than 3? So in that situation where we have an x and a y, we need two lines. And when we start talking about two lines, that's a coordinate plane. So we're going to start graphing linear inequalities, right? Not equations, but inequalities, using coordinate planes. And it's a 4-step process, okay? And I think you're going to get the hang of it real quick. The first step is we're going to make sure that the equation is written in slope-intercept form. So this one's good, this one's good. These bottom ones, right? This one's good, but these are in standard form, so we have to actually convert them. And the reason we don't graph them in standard form, where you could find the intercepts, is because if you have negative 3y is less than or equal to 12, when you divide by negative 3, you're going to have to flip this, right? And so then what do you do? If your y is a less than, but your x is a greater than, then things start to get confusing. So we're going to make sure that they're in slope-intercept form first, and then we're going to graph them. Step 2, plot points for the Step 2 is to plot points for the linear inequality as if you were graphing a linear equation. So we're going to graph this as if it were y equals negative 2x. So what's the y-intercept here? It's hidden, right? We start at 0. My slope is negative 2, so that means I'm going down towards the negatives 2 and to the right 1. Down 2, I've used my negative, to the right 1. So I have this line here. Now, when graphing regular inequalities, like one variable inequalities, there's a different way it looks if it's an or equal to, or if it's just a regular greater than. If it's an or equal to, we fill it in because it includes this number. Okay. Now it's the same thing with a graph, except we don't have a bunch of little holes, we have a line. So if it's or equal to, we're going to make a solid line. If it's not or equal to, right, this one is just greater than, there's no or equal to, then it's a dashed line. And we say it's dashed because it does not include the points on that line. Okay, it doesn't include these points. And that's kind of a combination of step 2 and step 3. Like we do with all inequalities, we have multiple solutions, right? So we have to shade. Here we would shade a number line by just drawing an arrow. When we have a coordinate plane, we're actually shading an area. And do we shade this area or this area? Right? So let's think about this equation. Y is greater than negative 2x. So the values of y that are greater than negative 2x. So it's actually going to be all those points that are greater than or above this line. Right? By above this line, I mean in like the y section. Kind of if you read it left to right. So this is the area that I'm shading in. Below would be below here. Right, below. But here it's all those values above. The other way you can do it is you can actually take a point and test it. So for example, if we wanted to test this point here, which is 3, 2. Let's see if it makes this inequality true. So y is greater than negative 2x. The y value is 2. Is 2 greater than negative 2 times 3? Right, is 2 greater than negative 6? It is. So that means that we did this right. Okay, this this point is in my solution because it makes the inequality true. If I were to test this point, it would make this false. Okay, so all these points make it false, all these points make it true, and that's why we have to shade in this area. I'm going to do this example with you, this middle one here, and then you're going to do the other 3 problems on your own and show your answer to your teacher so you can make sure you get it correct. So the first step, which we went over, is to put this in slope-intercept form. Right now it's in standard form. So I have to move the term with the x over, subtract 4x, those cancel. Negative 3y is less than or equal to, and I always put the term with x first, negative 4x plus 12. Last step, divide by negative 3. Right, every term by negative 3. Okay. When I do that, these cancel, and I have y, and I've got that golden rule. When you divide by a negative, this flip-flops. Y is greater than or equal to. Negative 4 or negative 3 is actually a positive number, so positive 4/3 x, that should be negative, right, minus 4. So there's my line in slope-intercept form, and I'm graphing that just like if this were an equal symbol. I'm going to start at my y-intercept, which is negative 4. My slope is 4/3, so that's up positive 4, right positive 3. And now I've got those 2 lines, or those 2 points, I can make a line. And you've got to ask yourself, is it solid or is it dashed? One thing you can always do is, if you have your pencil, make a solid line, and if you figure out it's dashed, you can just use eraser marks to make those dashes in. It's usually the easiest way to do it, or you can just kind of, as you go, pick up your pencil and make it dashed. This one is an or equal to. That means that it is a solid line because it includes those points. So I think that's probably the biggest one that I see students mess up, kind of the biggest mistake that I see students make, is they forget to dash this line. Okay. In this case it wouldn't be dashed, but in general, when they look at this, they kind of forget that, oh, I have to check if this should be dashed or not. Now step 4 is to shade. Am I shading below the line or above the line? So if you notice, my inequality symbol is greater than or equal to. So that's those y values that are greater than that line. So I would shade above the line. If you want to test out a point, okay, you can test out, the easiest point is usually 0, 0. And we can only test that point if it's not on the line. We couldn't test it in our previous example because our line went through 0, 0. But let's check and see if 0, 0 makes this inequality true. Is 4 times 0 minus 3 times 0 less than or equal to 12? So is 0 less than or equal to 12? Yes. So it would be shaded in the area that has 0, 0 which is this area up here. So your goal now is to finish the other 3 problems, and then you'll cut this out and you'll put it in your book for the entry called Graphing Linear Inequalities in 2 Variables. Now that you have it cut out, you can either title it up here in writing, or you can cut down this bottom margin and glue it up here. That's what I would do. And there you go. You're ready to continue practicing graphing linear inequalities, and the next entry you're going to be graphing a system of linear inequalities, which is very, very similar.